The next practical, frequency of AC mains by sonometer. We have to determine here the frequency of AC mains, that is alternating current, by using apparatus as sonometer. Now we have to perform this practical in two main parts. Number 1, using the wire of non-magnetic material as copper wire, and the second part, using the wire of magnetic material as Fe or iron wire. Now at the time of practical exam, these are the two different practicals. Practical 1 as determine the frequency of AC mains by sonometer using wire of non-magnetic material as copper wire, and the second practical may be to determine the frequency of AC mains by sonometer using the wire of magnetic material as iron. For performing these two practicals, we need the following apparatus: sonometer, step down transformer, electromagnet, bar magnet, slotted weights, meter scale, micrometer screw gauge, wire of non-magnetic material and the wire of magnetic material, and obviously there is a need of AC source as alternating current. Now this whole apparatus, this whole adjustment, this whole setup is known as sonometer. In that all these things are included. Here it is the AC source, it is total, this picture is for step down transformer, as in one lecture I have given, that is transformer. What is step down transformer, step up transformer, I have explained in that video in detail. Now it is the magnetic wire, a bar magnet used here for performing the experiment on non-magnetic wire. This non-magnetic copper wire is passed on these knife edges through this pulley, and to the other end we have connect here or adjust or apply the slotted weights in the grams of 50 or range of 50 grams. Now with these adjustments means it is a proper circuit diagram for performing the particle of the first part, that is by non-magnetic material as copper wire, and it is the second part diagram, that is it is the transformer and it is bar electromagnet. In first case we are using here bar magnet shown by N symbol, and for this second part we are using here electromagnet and replacing the non-magnetic copper wire by magnetic wire as iron wire, and the same situation is here, the slotted weights are here. Now for first part it is the calculation part, and for the second magnetic wire it is calculated part. I have been explained these two in detail while doing the calculation, but first before that we should clear the circuit diagrams. It is for second part, that is calculation of frequency for the magnetic material wire as iron wire, and that first was the copper wire. Now obviously in each practical we need some observations. Here also these are the interpretation of the given formulae. Notations: N equal to frequency of vibration of the wire, frequency of vibration N. L, length of the vibrating wire, may be magnetic, may be non-magnetic. M, capital M, mass attached to the experimental wire. Small m, mass per unit length of the wire, calculated by the formula pi r square rho. As its name suggests, mass per unit length of the wire, we have to consider 1 centimeter length of the wire, piece of 1 centimeter of the wire, and its mass to be calculated in this formula pi r square rho. Rho is the density of the wire. Small r, radius of the wire. Rho is the density of the wire measured in gram per cc. Capital N, frequency of AC mains of the wire, and this G, acceleration due to gravity at 980 centimeter per second square. Now while calculating the radius, we need the least count of the user apparatus, that is here least count of micrometer screw gauge is equal to the formula smallest division on main scale divided by total number of divisions on circular scale, and it comes out to be 0.001 centimeter. These are the required observations. Now the observation table for first part as determine the mass per unit length of the wire. One is for copper, another is for iron. The densities of both wires are given here. Now diameter of the wire measured in 3 trials, taking its mean, divided by 2 comes out to be radius, and by using this upper formula pi r square rho, we have to calculate mass per unit length of the wire, m equal to pi r square rho gram per centimeter. For copper it comes out to be 0.024 and for iron it comes out to be 0.01530. Now the first part of the practical, that is determine the vibrating length of the non-magnetic wire. It is this observation table. First column mass attached to the wire, second vibrating length for loading unloading, mean, then length square, then this m divided by length square and its mean. For both wires it have to be determined. Now 50, 100, 150, 200, 250 gram. These loads we have to add one by one. When we are adding this 50 gram load, we have to measure the vibrating length of the wire. Now what is its procedure? When we make the experimental arrangement, attach the 50 gram load to the free end of the wire, then by applying some voltage we have to change the positions of the knife edges. At that time the wire starts vibrating due to the electromagnetic wave, because we are applying only their alternating current or AC supply, and that AC supply is provided to the wire by means of bar magnet to this wire, and hence their electromagnetic field is produced, and due to that application of electromagnetic field the wire starts vibrating. And now we have to measure the length between two knife edges of the wire, that is the vibrating part of the wire. It comes out to be this. Now the same procedure we have to follow for different loads, 50 to 250. It is the completion of loading column. Now while performing the unloading column, as we have seen in the Poisson's ratio practical, observation starts for unloading from downward to upward. It is from upward to downward, and now it is in the reverse direction. Now as we are completing this loading and unloading, we take their average addition by 2. Then it is the average length, vibrating length, do its square, and it is mass column, it's a length square column, take their ratio, again take their mean, which is to be used for the calculation. Now the same part performed for the second type of wire as magnetic wire, as iron wire. It is same column mass, loading, unloading, and so on. Now here what is the difference in the circuit? The bar magnet is replaced by electromagnet, DC source is replaced by AC source, and we are performing the experiment. Means there is change in the magnet, electromagnetic field is developed there. One is for of bar magnet for non-magnetic material, and electromagnetic magnet is used for the vibrating part of the wire. It is copper wire and it is the iron wire. Now the same procedure, that is the application of slotted weights in the grams of 50, 100, 150, 200, 250. Here we have to perform first loading column, then from downward to upward in the reverse direction unloading column, take their average, then calculate the square, then it is mass column, it is length square column, take their ratio, and then finally take its mean for the calculation. Now by using this, actually we have to plot the graphs of that mass versus length square, mass on y-axis and length square on x-axis, and by plotting this graph we have to calculate here the respective slopes, and those two respective slopes we have to use here. That is for the non-magnetic wire, the formula will be n is equal to 1/2 square root of slope into g divided by m. This g is acceleration due to gravity, always should be taken in the CGS units. M is the mass per unit length of the wire, again it is taken to be in CGS units, and by substituting slope here, n is equal to 1/2 square root of this slope into g divided by m. This m column, first observation table will be there. Therefore from we pick up that value here, and we can calculate n is equal to 1/2 into this. After simplification it comes out to be 40.96 hertz by graph. Here you can proceed the result only by graph, it is sufficient because the experimental is somewhat lengthy. And that is why this capital N, that is the frequency of AC mains by sonometer, is equal to this. Now we move towards the second part calculation, that is for magnetic wire. Again we have to plot the graph of capital M, that is the first column of the observation table, versus L square. Then we have to calculate this slope, it is here G M. After substitution we need here the calculation n is equal to 60, but this n is equal to n by 2, it is comes out to be this. Now it is the result, n is equal to this by calculation, this by graph for first type of wire as non-magnetic material as copper, and for magnetic material for iron, those two values are comes to be here. These results are somewhat low, but the standard result for the frequency of AC mains by sonometer anywhere or in any condition, it comes out to be 50 hertz. It is a standard value because the supply of AC is used is of 230 to 240 volt and having 50 hertz frequency. Therefore the result should be in that range, that is, and the frequency is always measured in terms of hertz, that is the frequency of non-magnetic wire copper material is equal to N equal to 40.96 hertz. It is this present result, and for magnetic wire it is for this result. Now after manipulation of these two results, here ends this the explanation of this practical as determination of frequency of AC mains by sonometer. Now here also there are some oral questions. What is AC? Means what AC stands for, alternating current. What is sonometer? The total setup adjusted for doing the performing the practical, it is sonometer. Then what is AC source? What is DC source? Actually, what is do you mean by frequency? What is which type of wires are used in this experiment? Names of, give the names of the wires. These are the some oral questions for this practical. We have to write these practicals in your journal, and while writing this practical, at the end of each practical you have to write the oral questions with answers which will help you for facing the online practical examination.